Okay, so this video, my intention is to kind of do a real quick recap of all the things we've talked about in 3.1 through 3.4. Increasing, decreasing, concave up, concave down, relative min, relative max, points of inflection, all that good stuff. So on my original function, if I know that my original function is increasing, that is because my first derivative is positive. Okay, if my function is decreasing, that means my first derivative was negative. Okay. Another place we looked at increasing and decreasing was on the first derivative itself. If my first derivative was increasing, that's because my second derivative was positive. And if it was decreasing, that means my second derivative was negative. Well, both of those came in really handy because that helped us determine the concavity of my original function, which means this was concave up and concave down. Okay? Now, this is just the very basics of like, if this is positive, this is increasing. This is negative, decreasing. Same thing down here. Okay? Let's talk about, well, I guess there's another option. If it's not increasing or decreasing, it could be constant, which means my second derivative and first derivative, for that matter, are both equal to 0. Okay, so now let's talk about some special things that are happening in between. Okay, if you have a relative maximum on your function, that means on your derivative is equal to 0 or undefined. It's not defined there. And what is also happening, okay, now this is assuming that the point actually exists. It's not a vertical asymptote or anything like that. And your first derivative changes from, it's a relative max, so it changes from positive to negative. Okay? That's if we were using the first derivative test. If I wanted to use my second derivative test, this part would still have to be true, but furthermore, my second derivative, f double prime of c, would be positively not that. So sorry. My first derivative is equal to 0 undefined. That defines my critical number. I plug my critical number into my second derivative. If that number is equal to a negative, okay, so negative, that means my function is concave down, which means I have a relative maximum. Okay, a relative minimum is similar, but some things are basically the exact opposite. So f prime is equal to 0 or undefined again, and f prime changes this time from negative to positive. Okay, so instead of having positive to negative for a relative max, you were changing from negative to positive, so you're decreasing and increasing, and your second derivative, since your function would be concave up at that point, would be, oh my gosh, positive. I got this, guys, I promise. Okay, so this would be positive. Okay. The only other special thing we need to talk about is point of inflection. For a point of inflection, there's not really anything special to put in the first derivative column right here, but in the second derivative, okay, this is where f double prime equals 0 or undefined and changes sign. Okay, so remember, just because it's equal to 0 undefined means it's a possible point of inflection. It's not an actual point of inflection until you actually check to make sure that it changes sign. So you have to check for all of those things. Okay, so that's a real quick recap of this chart. I have another fancy version of this to give to you a little bit later, but you might, the more you write this stuff down, the better you're going to remember this stuff. Now, another thing I want to do is do a real quick breakdown of all of the testing that we have done this, I say testing, like candidates test and all that good stuff, okay? So, the candidates test Okay, the sole purpose of that is to determine absolute extrema. You can only use that on a closed interval as long as your function is also continuous. Okay, does anyone remember what theorem this went with? Anyone? Anyone? EVT, the extreme value theorem. Okay, so that is your candidate test. That is for determining absolute maximums and minimums. Okay, another test that we had was the first derivative test. Okay, this was to determine relative extrema. Now, some of these could be absolute extrema as well, but the test itself only determines the relativity of their extremeness, I guess you would say. You have to do the candidates test to determine absolute. Okay, so this can be on an open or a closed interval. Doesn't matter. As long as your function is differentiable, meaning you can take the derivative everywhere except possibly at critical numbers, which makes them, you know, critical numbers. Okay, maybe it's 0, maybe they're critical numbers. Okay, let's see, your second derivative test. Now, again, I'll do the second derivative in a second. So, second derivative, what? Oh, that's a V. It's like, what happened there? Maybe I can erase this. There we go. Div test. Again, is determine relative extrema. Okay. Same rules apply. Actually, the exact same rules apply. So I'm going to boop, 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 boom. Okay, so those are the tests. Now, we also looked solely at just the first derivative by itself. The first derivative by itself, not the word test, but just the word first derivative, is to determine intervals of increasing or decreasing. An application of the first derivative, of looking at your intervals of increasing and decreasing, helps you determine your relative extrema by also looking at the critical numbers. Okay, the second derivative is determining intervals of concavity. So if you throw in the word test, that means you're looking at the relative extremas. Okay, but if you're just solely looking at the first and second derivatives by themselves, they determine intervals of increasing and decreasing and intervals of concavity. That's the only thing they determine. Okay, so far this is all we've covered in 3.1 through 3.4. It doesn't seem like a lot now, but kind of is quite a bit. So I want you to make sure you really fully understand these concepts before we start into 3.5, which is where we're going to really just tie all of this in together into what we call curve sketching. So as long as we understand all of this stuff, then we could bring it all together and start sketching these curves.